On Friday, we talked about solving rational equations. So rational equations are ones that have variables in the denominator, or actually numbers in the denominator. And we started where if it's just a number in the denominator, like number 1, we're multiplying by the least common denominator to get rid of that. So what would be the least common denominator if my denominators are 9 and 3? 9. So I've got to multiply each of these by 9. The 9's going to cancel here. 3 goes into 9 3 times, so I'm going to multiply 3 times 1. 9 gets multiplied by the x, and 3 goes into 9 3 times, so I'm going to multiply the 3 times the 5. So I end up with 4x minus 3 equals 9x plus 15. And then I want to subtract the 4x. Negative 3 equals 5x plus 15. And then I want to subtract the 15. Negative 18 equals 5x. And then I divide both sides by 5, and I get x equals negative 18 over 5, which can get left just like that. You don't need to write it as mixed number form, okay? These don't have a variable in the denominator, so I don't have to check. I could just use that value to check to make sure my answer is right, but I don't have to check to rule out an extraneous root because there's no variable in the denominator. Number 2, however, has a variable in the denominator. So I have to remember to go back and check this one. If you want to do it from the beginning, you can say, okay, these denominators cannot equal 0, which means if I get an x that is 4, then I have a problem. If you want to do it from the beginning, do it. If you want to wait till the end, wait. Just make sure you check these. All right, so given that, my least common denominator here is x minus 4. So I'm multiplying x minus 4 over 1 times that first one. The x minus 4s would cancel. Equals 5 times x minus 4. And then the x minus 4s under the 12 would also cancel. So I'd end up with 3x equals 5 times x minus 4 plus 12. Distribute the 5 here to both, and I get 5x minus 20 plus 12. 3x equals 5x minus 8. Move the 5x to the other side, and I get negative 2x equals negative 8. Divide both sides by negative 2, and x is 4. Now, I said x couldn't equal 4 at the beginning, or if I'm checking them here, I would know x cannot equal 4. And since that's my only answer, I rule it out, and I would say there's no real solution here. Okay, the 0 with the strike through, or if it's on web-assigned D&E. Good morning, Natalie. Natalie, can you turn your camera on for me, please? All right, number 3, I've got a denominator that is x and x plus 1. So again, if I want to write the notes off to the side, x can equal 0 and it can equal negative 1 for me for later. My least common denominator is x times x plus 1. The whole thing cancels from the first one. Just the x plus 1 cancels from the second one, making this times x. And just the x cancels from the last one, making this x plus 1. So I get 3 plus 7x equals 3 times x plus 1. 3 plus 7x would equal 3x plus 3. Subtract the 3x. 3 plus 4x equals 3. Subtract the 3. 4x equals 0. Divide by 4. 0 divided by anything is 0, but I said it can equal 0. So here's another no solution or does not exist. And the last one we have to factor before we can find the least common denominator or the restriction. So this becomes x plus 3, x plus 6, x minus 3. Factors of negative 18 that sum to positive 3. So for my restriction, x cannot equal negative 6 or positive 3. And my least common denominator is x plus 6 times x minus 3. So for the first one, the whole thing cancels. The second one, the x plus 6 cancels, leaving me with x minus 3. And the last one, x minus 3 cancels, and I get x plus 6 here. So I get 1 minus 3 times x minus 3 plus 4 times x plus 6. Distribute. Oh, this is an equal sign. Equals, distribute again. Okay, I can add the 3x. I can subtract the 24. Divide by 7, and I get x equals -2. This was not one of my restrictions, which means I get to keep that answer, and my solution is x equals -2. Questions on any of the warm-up?
Wait, how did you cancel out the x plus 6, x minus 3 that was under the 1?
So this whole thing is my least common denominator, right? X plus 6 and x minus 3. They both cancel from the first one.
Oh, I thought you had to multiply that times the 1. Oh, never mind.
No, yeah, they're going to cancel. You want to get rid of that denominator, so they're going to cancel. Okay, so like I said, I will go back to that home. So this says solve and check your solution. If there's no solution, enter no solution. So I would want to get rid of the fractions, right? So I'm going to multiply everything by x. 12 would get an x. This would cancel out. 4 would get an x. And this would cancel out. So I end up with 12x minus 33 equals 4x plus 7. Then I want to move the x's to the same side, so subtract the 4x. 8x minus 33 equals 7. Add the 33. 8x equals 40. Divide both sides by 8. And x is 5.
Okay, I think I just did like a dumb mistake or something.
Okay. This is one we have to check though, right? Because that variable's in the denominator. So if we had gotten 0 as an answer, it would have been a no solution. All right. Any questions for me before I send you on your way? Question, what I want us to do is get through what we need to get through of 1.4a. So we're going to do 1.4a between two parts between today and tomorrow. 1.4 is solving equations that have x squareds in them. So solving quadratic equations. And we are going to learn several ways to do this. Sometimes you can choose which way to do it, and sometimes it's going to tell you specifically which way to do it. So you want to learn all 4 methods. Okay, but then at the end, there might be somewhere it just says, hey, you choose. Okay, so you want to make sure you know, you want to know all the different methods, and then you want to be able to do a specific method if it says to. So we're going to use something called the even root property today. Tomorrow we're going to do, I'm sorry, not today. Today we're going to use factoring. Tomorrow we're going to do even root property. Then we're going to do complete the square, and then we're going to use quadratic formula. So all 4 of these are used to solve quadratic equations or equations with an x squared. Today we're going to focus on factoring. So this says solve by factoring. This is what we're going to do. We're going to get all the terms to one side, setting the equation equal to 0. It has to be equal to 0 or the rest of this method can't work. We're going to factor the equation that's now on our left side, and then we're going to set each term or parentheses equal to 0 and solve it. So let's say we already factored the left side. We moved everything to one side. We factored it, and we have something like this, equals 0. So we just split and solve this. We would say not only does the x minus 2 equal 0, but the x plus 3 also equals 0. And I would get x equals -3 and x equals +2. Now the reason this works is your 0 property of multiplication, which says if this is 0, then I know my entire equation is 0, or if this is 0, then my entire equation is 0, because if I multiply anything by 0, I get 0. So this only works if it's equal to 0. I can't do this if it says like x plus 3, x minus 2 equals 1. I can't split and solve it if it equals 1. It's only if the number it's equal to is 0 that this works. And that's why our first step is to get it equal to 0. So they start like this. Example 1, get everything to one side. I already said equal to 0. That step's done for us. Now we have to factor this. So how do I factor x squared minus 1?
X plus 1.
Good. Different to 2 squares, x plus 1, x minus 1. And then I set them each equal to 0. So on the left, I get x equals -1. On the right, I get x equals +1. When you list your answers in WebAssign, it's going to say list them and separate them by a comma. Go to 2. Also already said equal to 0, but I got to factor it. How do I factor this one?
Take out x.
Good. Take out an x, and I get 3x plus 1. Then I set each of these equal to 0, and I get x equals 0. 3x plus 1 equals 0. Subtract the 1. 3x equals negative 1. Divide by 3. X equals negative 1/3. So I get negative 1/3 and 0. Everybody still good? All right, so 3, is this equal to 0?
No.
Good, it is not. So the first thing I have to do is move the x over to here with the x squared. So I'm going to do x squared minus x equals 0. Then I factor by taking out an x, and I get x minus 1. X times x minus 1, split them, set them each equal to 0. And I get x equals 0 and x equals 1. So my answers are 1 and 0. Last one on this slide is set equal to 0, but I have to factor it. So this is my first trinomial. I'm looking for factors of the last number that sum to the middle term. What two numbers multiply together to give me negative 8 but add up to positive 2?
Negative 2 and 4.
Good. Negative 2, positive 4. Split them and solve it, and I get x equals 2 and x equals negative 4. Those are my answers, negative 4 and 2. Easy stuff, right? It's just that factoring's not going anywhere. I warned you. You've got years of factoring ahead of you. All right, go to 5. Already said equal to 0. This time, everything's on the same side. I got to factor it. This time I've got a number in the front. Remember that we have two choices, either trial and error or first and last. So I'll do first and last this time. 2 times negative 15 is negative 30. Factors of negative 30 that sum to negative 1 are negative 6 and positive 5. Substitute those in for the middle term and then factor by grouping. From the first set of parentheses, I can take out a 2x. Second set of parentheses, I can take out a positive 5. X minus 3 is in common, so I take that out, group together the 2x plus 5. Set each of those equal to 0. I get x equals, x equals 3 here. 2x would equal negative 5. And x would equal negative 5 halves. All right, you do 6. Actually, do the rest. 6, 7, and 8. Do the rest on this slide. All right, so for 6, you had to move the 3 to the other side before you can factor and solve it. Move the 3 over. And then I did trial and error. This time I get 2x plus 1 and x plus 4. Solve them both, and you should have gotten -1/2 and -4. Going to 7, you have to move the 3x over. Move the 3x over, take out a 3x, and you would have gotten 3x times 2x minus 1. Split and solve, and you get x equals 0 and x equals 1/2. And 8, move the 2x over, take out a 2x, and you get 2x times 4x minus 1. Split and solve. And you get 0 and 1/4. Questions on any of those? Okay, so be so careful, because what tends to happen on things like these is, let's say I have 6x squared equals 3x. Now, technically, I could divide both sides by 3, and I'd get 2x squared equals x. And then people tend to come over here and divide both sides by x. And you end up with 2x equals 1, and x equals 1/2, which gets you one of your roots. But you lost the x equals 0 here by dividing by x. So do not do that process. You want to factor and solve. You don't want to divide and cancel here. Be really careful, okay? Because 0 is a root or is a solution to this equation. And if you divide both sides by x, you lose it. So again, be really careful. So for these, we're going to factor and solve. All right, number 9. This time I have 2 things to move over, but it's the same. I'm just going to add the 6x. I'm going to add the 9, and I get x squared plus 6x plus 9 equals 0. Now I'm looking for the factors of positive 9 that sum to 6, which are 3 and 3. Split and solve these, and both of them give me an x equals -3. So it's completely normal, and sometimes it's going to happen, to get 2 of the same answers. You just need to list them once. So -3 by itself would be the root. Okay, go to 10, 4x squared plus 12x plus 9. Again, 2 processes here. 2 options. I can either do first and last, or I can do trial and error. I'm going to do first and last. So 4 times 9. 36. Factors of 36 that sum to 12. 6 and 6. Replace the middle term with positive 6x and positive 6x. Factor by grouping. Take out a 2x here, and I get 2x plus 3. Take out a 2 here, and I get, take out a 3 there, and I get 2x plus 3. And my result is 2x plus 3 times 2x plus 3. Set them each equal to 0. And I get -3/2 twice. Now this is actually a perfect square trinomial. So if you had caught it from the beginning, the shortcut would be square root the first term, square root the last term, take the sign from the middle, put it in parentheses, and square it. I would still know there's 2 of those, and I can set either of them equal to 0. And I'd still get -3/2. So it doesn't matter which process you use, you should end up with the same answer. Still with me? Okay, 11, factors of -8 that sum to -2, -4, positive 2, split 4, -2. And the last set, number 12, -x squared plus 4x equals 3. Now, I like my x squared's positive, so you can move these in either direction, which means I can actually move that x squared to the right side. You don't have to do this, but I would move the 4x by making it -4x, move the -x squared by making it positive x squared, and rearrange my terms so that they are in order of decreasing degree. Then factors of positive 3 that sum to negative 4, negative 1, negative 3. Split and solve, and I get x equals 1 and x equals 3. So you can move those to either direction. We tend to move from right to left just out of habit, but you can certainly move them in either direction. Questions on that one? Okay, 13. Freak out. It's a fraction. Do we know how to get rid of fractions? What would we do?
Multiply the equation by the denominator.
Good. There's only one denominator, so I'm going to multiply everything by it. It's going to cancel from the first one. I'm going to multiply 8 times the x here. I'm going to multiply 8 times 16 here. I'm going to multiply 8 by 0, and it doesn't matter. It's going to go away. So I end up with x squared minus 8x. 16 times 8 is 128 equals 0. With me so far? Now I need the factors of negative 128 that sum to negative 8. We just did it, right? We just did negative, or it would have been a positive 8 and a negative 16. Those two numbers when multiplied together give me negative 128, and added together give me negative 8. So I get x plus 8 and x minus 16. Split and solve, and I get x equals negative 8 and x equals 16. Questions on that? All right.
I
So,
missed number 8. Can you go back to that?